Good afternoon. Welcome to Ruby University. Thank you for joining us today. Today's session is Constructability for Fabricators, and myself and John Matusk will be presenting. My name is Jay Ruby, President and CEO of Ruby & Associates Structural Engineers. Degree from Penn State University in the AE program, and been in the building, design, and construction industry for over 20 years. And what we're going to be talking about today is constructability. And a lot of what we're going to go over today is in the Design Guide 23, written for designers. But today, what we want to do is paint the picture, show how this document can help you as fabricators to do your job better, to work with the building team better, to expand your role in the building delivery process, and to become a value-added part of the team, and try to get away from being the low bidder or low-cost provider. In that, there's a number of things that get into that, into constructability. We have today's existing business culture. Everybody wants more for less. They want to tell you how the prices are out there, how cheap things are, and where your number needs to be for you to get the project. Building codes, they're changing constantly. There's a lot of outside things getting involved in building codes, not just life safety, but material usage, energy usage, and those kind of things, which gets into sustainability, how that affects our industry with green lead points, recyclability, and those kind of issues that for most of us really aren't aren't necessarily a part of the steel design, fabrication, erection process, but more and more it's getting into the world where we work. Project delivery systems. Are you working strictly in design, bid, build? Are you working in design build? Are you getting involved in IPD? Are you teaming? Are you working with CMs? All those kind of things that we deal with every day. Constructability can help you deliver in all those realms better. Technology today, 3D modeling, which the steel industry has really been a leader in for years, ahead of the curve. Now there's a lot of other people getting involved in that. How do we work with that? How does our model work with other models? Is the model formatting, does that help us? Does it hurt us? Do we have to build our own model just because that's the way the steel industry is doing, or can we interface with the architect's model and other people's models on the project? Costs. Where are costs going? The price of steel fluctuating, the price of labor fluctuating, and how does this all work? A lot of people, outside of our industry really want to talk about, hey, what's the price per ton? And really that's a matter of, at the end, you have a tonnage and you have a price. So you do simple math and you have a price per ton. But we all know that so much more goes into pricing a project. We get into bolts, number of pieces we're handling, how many times we're handling them, how many trucks are going out, what's the shipping schedule. All those things go into your cost that generate that quote-unquote price per ton. But really, when you look at a project, you're not looking at price per ton. You're looking at, hey, where are my man hours? Where can I eliminate man hours? Where can I be more efficient? Where can I do something smarter so I can get this job? And then schedule. Schedule these days are getting pushed and more. They're bringing up, hey, you're using technology, so you can do this all much faster. You can get us to the end much faster. So we can take much more time at the beginning to wait on making decisions, but we'll hold that end line for you and keep pinching us on schedule. So getting involved early in a project as fabricators, you can have impact on the design, working with the construction team, working with the build team as to your role, what do you play, how can you be a bigger part of it, how can you have more control of your own destiny. I'm going to put a curve up here. It's really talking about when you look at a project when it starts, you have your concept and feasibility phase at the beginning, and any decisions that are made in that early phase, there's really not a lot of effect on the actual cost of the project. So if you change something, the cost to make that change is minimal. It's kind of just a normal process. But the farther along you get in a project, the more costs can be associated with changes of maybe it's doing something better for the steel, but it has ripple effect in other areas that have to be coordinated or redone. So the cost of that change or modification increases as the project goes along. And the costs go the other direction. So the longer you get in a project, the less opportunity you have to change something and to have an effect on the cost of the job. And then any change that do happen, the cost starts going up. And then just a chart which I'm sure many of you are familiar with, seen in modern steel, but just going over the years of the cost of material, shop labor, erection labor, and other costs. Material prices have come down. They have gone up in recent years and have fluctuated. But when you look at the labor portion of these two charts, the shop labor and the erection labor, that's still the lion's share of the cost these days. And that's really where money gets eaten up in you handling things multiple times. How many pieces are you handling? How many shipments are you making? So constructability focuses in on this shop and field labor time and where you can best spend it and how best you can deliver projects. With that, I'd like to introduce John Matuska. He is a graduate of University of Michigan with an MS in structural engineering. He's been working at Ruby for 17 years. He's been engulfed in the constructability mentality, working for Dave. He's been involved in a number of industrial, manufacturing, and healthcare projects. And he will be getting into Design Guide 23 and case studies and how this applies to your business. Thank you.
Well, our goals for today, as Jay discussed, are we're going to go over Chapter 5 of Design Guide 23, which addresses fabrication issues mainly. To give you a definition of constructability, the official definition, I'm not sure there is one. In 1993, the Construction Industry Institute defined constructability as the optimum use of construction knowledge and experience in planning, design, procurement, and field operations to achieve overall project objectives. That pretty well encapsulates what we're looking at. I guess what we're emphasizing with constructability is collaboration between all the trades, design and field, from the inception of the project. So again, we're going to go over Chapter 5 of Design Guide 23. We're going to discuss a couple case studies and a couple business opportunities. When I say business opportunities, what I mean is the traditional construction method, you've got fairly fragmented sources of labor. You've got the structural designer who's designing, the fabricator who's fabricating, the detailer who's detailing, and the erector's erecting, and they're all doing it kind of out on their own islands. There's not a lot of collaboration between them. What constructability is preaching is obviously collaboration from the beginning. So as far as business opportunities, we're looking at how you can maybe change your mindset to become a value-added provider within this construction process, rather than just the guy who's detailing and fabricating the steel. Value added meaning someone who can provide valuable input to your client, whether it's the owner, the GC, or CM, valuable input with regard to schedule and the real cost of the project. As Jay said, not just the tonnage, but the man hours involved in getting that steel to the site and getting it up. I'm probably not going to be telling you anything you don't already know today, but hopefully this presentation will help you think outside the lines a little bit, as far as the traditional construction process delivery goes, where design, detailing, fabrication are all distinct functions. Constructability philosophy wants to integrate this whole process from project inception. Oh, yeah, sorry. The professional development hour code for this session, and I'll give it at the end as well, is V as in Victor, D as in dog, 97, F as in Frank. So section 5.1 of Design Guide 23, constructability philosophy emphasizes complete and coordinated construction documents. I'll start with the trend today. Traditional delivery, fast-track design. Structural engineers, and I'm just speaking from my point of view on some projects in the past, structural engineers given 6 weeks to provide either construction documents or bid documents, 6 weeks to design this 200,000 square foot facility. 4 weeks into the process, the architect's only about 50% of the way through his drawings. So obviously what you're going to get as a fabricator, either with the bid docs or the construction documents, isn't a complete set of documents. And typically in this delivery method, at the end, the structural engineer is hustling to try to get the architect's updated information on his drawings, so he doesn't have time to worry about things that are going to matter in the field, things such as connections, erectability of the structure. Can't really, in this traditional method, you end up with incomplete and uncoordinated drawings that don't have dimensions, again, incomplete connection information. Obviously, the fabricator gets those drawings. It's going to lead to inaccurate bids and inaccurate project proposals. You're always going to get design revisions during the project, either in the traditional method or constructability. How it's handled varies a little bit and is, we would say, improved in the constructability method. But all those revisions and those inaccurate bids are going to lead to RFIs, schedule delays, lost profits for everybody. Project's going to be over budget. You're going to end up with an unhappy owner who's unlikely to come back to the project team for his next project. That's obviously not a good scenario. And obviously it doesn't happen with every traditional delivery method, but it's somewhat the norm. So constructability preaches complete and coordinated construction documents, sufficient drawing, coordination, and detail to allow accurate pricing estimates. The drawings should be coordinated with the architect's documents. They should have proper dimensions, should have all your members on there, should have proper complete connection design information, and if you don't have all the connection details on there, you should at least have enough information for the fabricator who's pricing that job to either give it to his detailer or connection designer and be fairly confident that what he's pricing is actually what the job's going to need. A lot of times when the connection design information is incomplete, you're looking at maybe the minimum connection that the structural engineer would accept, putting that into your price. You come to find out that's not correct, so the job's, again, flooded with RFIs and extras. So constructability preaches from the outset complete and coordinated construction documents. Also, concise project specifications. I know everybody's gotten their bid documents and you get 4.5 inches of an 8.5 by 11 spec. Maybe only 10 pages are relevant to the job. Obviously, there's always a lot of boilerplate in a lot of the specs you get. We seek to avoid that, verify compatibility of that spec with the drawing, and again, eliminate irrelevant information. So, with the constructability process, structural engineer does a great job producing his complete and coordinated documents. Fabricator gets the bid drawings, produces a good number. There's 0 RFIs on the whole project. This is just a for instance. Fabricator gets the job, no RFIs, everybody's happy, right? Well, everybody probably is happy, but it's likely that there are still opportunities where early involvement from the fabricator could have made the project a lot more successful from the owner or the general contractor's point of view. Jay showed you part of this graph a couple minutes ago. The axis on the left side is the ability for design decisions or decisions in general on the project to influence the outcome of the project. And the bottom axis is time. Generally, in a traditional design bid build project, the first time you see the drawings during the bidding phase. Obviously, getting that far down on the graph, your ability to influence the project with any suggestions you make, which are typically called value engineering at that stage, your ability to influence the project has been severely limited just due to the time. You don't have a whole lot of time left. The structural engineer, if you make suggestions at this stage, structural engineer is usually going to be a little offended, see that as a critique of his design. You know, we all have pride, and we don't like to see our stuff ripped apart. And even if they're good suggestions, sometimes there's resistance. There's always some time lag before those changes can even be implemented. So constructability is not value engineering. Again, we preach collaboration all the way up here at conceptual planning. The next time you're going to likely see that or make any changes is during fabrication and erection. Typically means and methods. Those are usually good suggestions, but again, it may be too late along the constructability influence curve here to have a significant effect on the project. So constructability is not means and methods either, not strictly means and methods. So with the collaborative design process, you get maximum ability to influence the cost and schedule of the project. If you've got a fabricator involved, a fabricator, a detailer, or a erector involved from project inception, you can get good input on some of these things. I went to a seminar this morning, 122 design tips for structural engineers. All the things basically he went through are things that we consider during a project. But a lot of times, unless a fabricator is sitting, it's always more useful to have a fabricator proofreading I won't say proofreading because that puts more of a burden on you, but all 122 of those tips were things that I've gotten from a fabricator or things that lessons we've learned from fabricators over the years. So people walking out of that are trying to remember all 122, and there's actually 1,122 tips that, you know, a fabricator could typically give a structural engineer on a project once he sees the drawings early enough. A couple examples: repetition of beam and column sizes. Structural analysis software these days optimizes member sizes so that you get the most efficient member size or the lightest member size. That analysis program then spits these member sizes out onto a drawing. Fabricator gets them, puts a price on them. Typical example would be, let's say you got a 20-foot bay. You got 200 of these beams. The analysis program, some of them are slightly differently loaded. For that 20-foot span, you get a couple 10 at 15s, a couple 12 at 14s, a couple 12 at 16s, a couple 14 at 22s. In that example, you've got 4 different groups of beams that you need to track, to detail, again, track in the shop, handle, keep track of on the site. I've had jobs where the fabricator said, well, you know what, we saved a little bit on tonnage, but we're costing the project more because you've got a lot more overhead man-hours tracking all these different beam sizes. So grouping different beam and column sizes, that's one example. Fabricator can have good input on wide flange versus a built-up shape or even a truss. Which one would be more economical? Truss geometry and layout and member preference in trusses. We've got a job in our office right now. I think there's 120 total trusses on the job, 120 truss pieces on the job. I think they're all about the same span, is that right? There's 56 different truss types out of 120. So even if you cut that in half, you got 25 different truss types. You've saved the whole job a significant amount of cost. So truss geometry, input like that from the fabricator is very valuable. Connection details we're going to go over at length in a little bit. Camber, the structural analysis program spits out all the beams, and every one of them has an inch of camber. Obviously, maybe you want to go to a deeper member, something a little stiffer, and avoid that camber. Facade details. Usually in the traditional method, by the time you guys look at it, it's at bid docs. The structural engineer and the architect have already spent a decent amount of time on the facade connection details. Those details always seem to have a lot of shop time and a lot of field time involved in them. So any input you can have on those details earlier is obviously going to be a benefit to the job. So again, the architect, even in a model, even in a delivery method, a job that uses constructability as its philosophy, the architect's never 100% complete by the time the bid drawings go out. There's always going to be changes. The jobs are always pretty dynamic. But collaborative design with involvement from all trades, from project inception, on basically every job I've worked on that emphasizes this, has proven that it's shown that you're going to get more complete and coordinated design documents just by the simple fact that the fabricator is in your ear from day one. There's certain things he's looking for on the drawings. Those things usually don't factor in the structural engineer's decision matrix as he's going along. They may later on, but the earlier the fabricator can get involved, the more benefit it is to a project. Section 5.2 deals with material procurement and shop drawing fabrication. So just from the standpoint that you've got more complete and coordinated design documents, constructability philosophy inherently streamlines material procurement and the shop drawing process. From a material procurement standpoint, obviously the complete and coordinated design drawings will allow for a more accurate takeoff on the steel. You've also got input on member sizes. You can give input on long lead items or suggestions on changes to make. Another thing, with the advent of BIM, which we're also going to talk about a little bit later, I guess there's less reluctance over the past couple years to give the model to the fabricator. The structural engineer, obviously, there's liability issues involved with giving the fabricator his model. I know that sometimes the fabricator, when he submits his price to the general contractor, one of his assumptions is you're going to get a model. If you get the fabricator involved earlier from project inception, the fabricator and structural engineer, develop a relationship. There's more trust. So the structural engineer is a lot more inclined to just give that model to the fabricator. The earlier the fabricator gets the model, the more useful it is. Usually the fabricator, if he does get the model in a design bid build project, it's after he's already gotten the project. How useful would that model be when you're bidding the project if you know it's an accurate model? You just push a button, boom, you've got material lists, you've got your piece count, your tonnage. Save you guys a lot of time that you could spend actually planning how you're going to do the project. So, that's something that's has been developing over the past couple years, but with our constructability philosophy, if the fabricator's involved from project inception, you're going to have a lot more useful model, save a lot of man hours. Shop drawing prep, if you've got complete and coordinated design drawings, developed with detailer input. So, the detailer doesn't get the bid drawings and have to start detailing a week later based on some assumptions that are incomplete on the drawings. If you've got complete drawings and the detailer and fabricator have been involved from the beginning of the project, the shop drawing preparation process is going to go a lot more smoothly. You've got standard details and connections that you've previously discussed. With the relationship that the fabricator and detailer and engineer have developed early on, the RFI process is a lot less adversarial. And again, shop drawing prep with a BIM structural design model, obviously a lot easier. You can hit the ground running with that model, use it as your detailing model. Shop drawing review. The examples that I'm going to give as case studies a little later on. The shop drawing review, the average review time in our office is typically about a day. Just because there aren't any surprises on the drawings. We've worked with the detailer and the fabricator earlier on in the project. The fabricator knows what we'll accept. We know what the detailer is going to give us. So the shop drawing review process is just streamlined quite a bit. With a BIM model, obviously, you can do on-screen checks. You can just go through the building. You don't have to look at every single drawing, depending on however, what the contract says, that can streamline it even more. Section 5.3, standards. Obviously, some of the big ones, AISC, AWS, ACI, typical project standards. But it's usually good to have these discussions early on in the project with the fabricator. For instance, within AISC, has the architect got a lot of stuff that he wants to be architecturally exposed structural steel? Well, in the traditional method, you just outline what that is on the design documents. There could be things that the fabricator can produce that'll look just as good that don't necessarily need to conform to that. Or the fabricator could have some ideas, or at least give the client, the owner or the general contractor, an idea of what the cost of that architecturally exposed structural steel actually is. So you can either make some changes to that or eliminate it from the project. And usually what you end up with, based on quality standards in shops and in the field today, is something that still looks pretty good. ACI, something to discuss that the fabricator should be aware of early. It came up on one of our projects a while ago. Something like floor flatness tolerances. A lot of times, someone's nodding his head down there. Were we on that project together?
We just got burned by that.
Okay, yeah. I mean, member sizes, pour sequences, having the fabricator or erector, someone with a knowledge of steel in that room when the concrete contractor is going over his pour sequences, very helpful. Other AISC standards, specifically seismic provisions for structural steel buildings. The geotechnical engineer at the beginning of the project gives the structural engineer his assessment of what the seismic site class is. From there, the structural engineer has a little bit of latitude in determining the seismic response modification factor. That's R. With an increased R value, your tonnage goes down, but your connections just, you can get murdered on the connections. If you decrease the R value, your connection cost goes way down, but your tonnage might go up. There's a trade-off there, and usually, depending on the facility, the site, that's something that the fabricator can have very valuable input on. Obviously, you've probably all worked on jobs where the seismic connection detailing, a lot of man hours, both detailing, designing, and in the shop and in the field. So fabricator having input when the structural engineer is determining that R value, very helpful. Secondary standards that should be discussed early on if the fabricator gets involved earlier. AIST Technical Report 13 for mill buildings. There are tolerances in there which are far more stringent than most AISC tolerances. And if you go in just assuming you're going to fabricate and erect to AISC tolerances, the owner or the engineer comes back and says, no, this was supposed to be to Tech Report 13 tolerances, you're going to have a big squabble there. Other things, factory mutual guidelines, obviously some guidelines in there that are more stringent than AISC or IBC or other building codes. So just secondary standards that aren't on every project, but things that need to be gone over early in the project. Section 5.4, connections. Obviously, with earlier fabricator involvement, the fabricator and detailer, one of the first things they're going to be looking at is connection design. A lot of drawings, and it kind of goes with the scenario that I mentioned earlier. The structural engineer's got a tight design schedule. He's late getting his information from the architect. He's coming down to the 11th hour. He's more worried about getting the footprint right, getting member sizes on there. So he uses general notes to address connection design information. Things you guys have all seen on drawings. Usually cost the job a lot of money, and with a little input from the fabricator and maybe a little more time from the structural engineer, these things can be avoided. So complete design drawings should include complete design connection design information. Material thicknesses, welding and bolting requirements, stiffener and web doubler requirements, or if you don't have every connection drawn on the drawing, as I said, should at least have sufficient information for the fabricator's connection designer to give the fabricator some idea of how much it's going to cost him to produce those connections. Early collaboration from the fabricator. If fabricator gets involved early enough, he sees the drawings as they're in progress, can point out connections like this. This was the only representation of this connection on the drawing. It is and I got to get the description right, I stole this from Dave's earlier presentation today, but this is a partial fifth floor plan of a 30-story structure, and in summary, there's significant horizontal forces into this concrete shear wall. But this is the only representation of this connection on the bid drawings. So a fabricator got these drawings, looked at this, figured, yeah, we got some skew connections, got some axial forces, throw some money at it. This is what the connection designer had to do to get those forces into that shear wall. This is a embedded shear plate that had to be put into that wall. And that's a Tekla model of that connection. Now when you guys got the bid drawings and looked at that, we're pretty sure you didn't price that. So obviously that was a problem on that project. I'm kind of going to breeze through this just to save a little bit on time. Obviously, fabricator early involvement. You can have discussions on bolted versus welded connections. Obviously, connection design choice has a significant effect on cost schedule and inspection criteria. We'll discuss that in a couple minutes. Bolted joint considerations. Are you going to use AISC standard connections? Probably a pretty good idea if it works for the projects. Certain, different fab shops have different preferences, things to discuss early on. Tightening methods. Snug tight versus fully tensioned or slip critical. A lot of times a structural engineer won't give this much consideration. Obviously, slip critical connection a lot more from a fabrication and erection cost standpoint, but also with Chapter 17 in the International Building Code, special inspection requirements. A slip critical connection requires continuous inspection. A snug tight connection requires periodic inspection. So just outside the realm of connection design, detailing, fabrication, and erection, yes?
Would you say to fabricators to often question if there is a fully tensioned joint to ask if it can be snug tight? Would you say most engineers maybe could make that change? Or
I would say if it's early enough on in the project. I talked a little earlier about when that suggestion is made. Like I said, we all have pride. Structural engineer produces his bid documents. Fabricator comes back and rips apart all his connections, say, no, that's too expensive. I want to use snug tight. I don't want to use fully tensioned. Just having that discussion is going to take a couple weeks. The wise engineer will relook at it and probably do what's best for the client. If you get that discussion earlier on, you've streamlined it. You don't lose that discussion time later on. That's something in our office that we always look at. From day one, Dave and Jay have been on me about connections. You're not just pulling stuff out of the AISC manual. Somebody's got to build this in the field, and everything. Dave had a couple slides yesterday, a slip critical joint cost versus a snug tight joint cost. And that's something that within our office, we've been thinking about it. I've been thinking about it every day since I've gotten there. Most engineers probably would consider that, depending on who the connection designer is, who the detailer is, and who the structural engineer of record is. So a structural engineer who's concerned about the project and looking out for his best interest will consider that. So again, tightening methods don't just affect fabrication and erection. It also has an inspection cost that's going to be borne by the owner. Other bolted joint considerations, are there certain connections that the engineer has laid out that are going to require oversized or slotted holes? And when he sees the connection as designed, is he going to accept those oversized or slotted holes based on how the force goes into the joint? Welded joint considerations, different joint types, how many times does the thing have to be turned in the shop, access in the field, welding processes. Welding process is usually best addressed by the fabricator or the erector, or at least have some input on them. Weld all around symbol, pretty common on a lot of drawings, but seldom is it necessary. And again, with welded joints, quality and inspection, different weld types require periodic inspection. Some require continuous inspection. It's a big cost difference there. Section 5.5, surface preparation. How many fabricators in here have seen drawings or spec that had a surface prep requirement that was way beyond the call of duty? Yeah, and how many engineers have specified one that was way beyond the call of duty because you got to the 11th hour and just sent out a spec that had SSP5 white blast cleaning on it, you know, something that wasn't required on the project. Getting the fabricator involved earlier on, knowing what that surface prep requirement is, can save the owner a lot of money on something that, you know, may or may not provide some value to the project. Section 5.6, galvanizing and coatings. Obviously, the coatings have an implication on performance, schedule, and budget, but you know, sometimes paint or steel doesn't even need to be painted. If it's an interior surface that isn't exposed to moisture, doesn't need much surface prep at all, and doesn't need to be painted, it can save your owner a lot of time by discussing that with him early on. We've got a project right now where the paint spec is just, I mean, it's way over the top, costing the owner millions. It's something that he wanted because he's had it in his buildings all along. It's just his standard paint spec. Well, every surface on this building is going to be covered with grease and dirt within 2 years, so you're not going to see the paint anyway. But it's costing the owner a couple $1 million at least on the job we're working on. I kind of look back on this project, and it was traditional. It was design, bid, build, and I think if either a fabricator or someone knowledgeable on paint specs could have been in the owner's ear early on, probably could have saved the job a lot of money, and the owner probably would have been pretty happy. But fabricator getting involved early on to discuss those things, very helpful. Shipping and delivery, section 5.7. Piece sizes. We had a job a couple years ago where the fabricator was involved earlier. We came in with our preliminary design. It was a laced crane column. Center line of column to center line of column was about 13.5 feet. Once you put the flanges on there, we were about 14.5 feet. We talked with the fabricator and the erector, who was also involved early. You know, what should we do? Should we send it out in the field as sticks? Should we fab it in the shop? Tighten up the column gauge a little bit, send it as an escorted load, different things like that, that having more people involved early on can really help the project from a cost standpoint and a schedule standpoint. So the sections in Design Guide Chapter 5 that address fabrication, again, all of these things are on the Structural Engineer of Record's decision matrix, but each one of these can be done without fabricator input. But with fabricator input, the examples I've given and the case studies I'm going to go through, fabricator input can provide a great cost benefit and schedule benefit to the client. And what I know a lot of you have been involved in projects where you've gotten earlier input and seen the successes of those. And sometimes Jay and Dave and I talk and make the comment, you know, we're giving these presentations to the wrong people. We should be giving it to the owners, because the fabricators already see this stuff. The owners need to see it. So, you know, if you've got an owner's ear, we've got these presentations are going to be on Ruby University. I'll give the website later on. AISC will have them. Any facts or figures you want to take to an owner, have at it, because, you know, it's them that we need to be proving this to. A couple case studies. First one, Mercy Health Partners. This is actually two case studies. The one on the left is a 4-story, 144,000 square foot hospital. The one on the right is a 3-story, 200,000 square foot hospital with a 50,000 square foot MOB on the side of it. So I'll run through some technical information, or I'll run through some fabrication discussions we had on the 3-story one first. Okay. For both of these projects, the owner realized early on and had taken this project delivery concept, which essentially mirrors constructability. He'd used this on a couple projects to a great level of success before we got involved. But he got more people involved earlier on with the projects we were involved with, and the focus was always on the finished project produced by the project team. From day one, we had project meetings where everybody was involved. The fabricator was involved from day one, mechanical guy, fire protection guy, everybody from day one. We had weekly or bi-weekly meetings until the project was done in the field. The deliverable was always the finished operable building. It wasn't a set of drawings. It wasn't a set of shop drawings. It wasn't a model. It was the finished project. Drawings based on a collaborative effort of the design team focused on economy of construction. Again, it was the total project cost. It wasn't just the tonnage of the steel tonnage. It wasn't really anything you could measure in the traditional sense. It was the total cost of the project. Again, full team meetings, no disciplines removed from the project. Everybody sat in on those meetings. They knew all of the challenges, and even something that I sat in on a hospital design seminar yesterday afternoon, and it was really good, but one of the things they discussed was depressed slabs in the floor, and how typically the architect doesn't know, the project team doesn't know where those depressed slabs are going to be until sometimes till you've got the steel up in the field and the concrete guy's ready to go in there. We had some depressed slabs on these projects, and it was discussed early on in the project. It was just kind of a matter-of-fact comment by the architect. We've got some depressed slabs that might require some special framing, but we don't know where they're going to be, so there's probably going to be a lot of field coordination involved and extra costs. Fabricator's ears perked up. He immediately addressed the situation, say, well, okay, if we know that going in, if you know in general where they're going to be, we can use this detail. You just drop the slab down there. We don't have to thicken the whole slab and then make it thinner at the depressed slab area. So just things that you might not even think, or that an architect wouldn't even think you'd have valuable input on. If you're sitting in those meetings, you might waste 59 minutes out of the hour, but that 1 minute can be very valuable. So full team meetings from the beginning, very valuable in this project. This is, we designed this 3-story hospital, about 200,000 square feet in RAM. And I had some animation, but we took it off the stick and then, oh well. But we designed this thing in RAM, and the owner was pushing the fabricator for budget information. So we gave our preliminary model to the fabricator. Basically, he just pushed a button, got the material order, got the tonnages, piece counts, able to give a fairly accurate estimate to the owner. That's something we talked about earlier, big benefit to early collaboration. Plan view of this, obviously a lot of floor beams, metal deck with concrete on top. You're going to have a lot of copes. I'll back up. This was an overhanging roof that had roof pitches going a bunch of different ways. One of those things architects do to jazz up a hospital building. These were short cantilevers coming off. Fabricator got his input, said, you know what, we're gonna shop weld those cantilevers. It's kind of hard to tell exactly what's going on here, but and I apologize for the hot pink color here, but it gave some good contrast. But details like this, the fabricator saved the job a lot of cost and schedule with shop welding, which typically probably might have ended up as a field weld. Or some bolted connection that could have cost more money in the field as well. One of the things the fabricator requested early on is all those floor beams, he didn't want to cope all of them, just drop them down a couple inches, put the deck right on top of the beam, and then the deck will run right over the top of the girder. Probably 450 floor beams on this thing, saved 900 copes, obviously a lot of shop time saved. Another thing, there were a couple entry canopies around the hospital. The architect's concept was this treed method. This was his original concept sketch. This was his sketch also. What he wanted to do was have 5 individual pipes and then a downspout. So these are 5, I think they were approximately 6 or 8 inch diameter pipes. And again, those are all spidering out at different angles. 5 different ones welded together to support this 10-foot cantilevered overhang. Fabricator, we looked at this, tried to make it work for a couple days, finally realized, you know what, the way to do this isn't with 5 individual pipes. It's going to be a nightmare to fabricate, going to be a nightmare to erect, and there were also corrosion problems we were going to have with the field welds. So we had started developing this model, bounced a couple ideas off the architect, said, hey, we can, with the fabricator's CNC cutting, we can just cut these round tubes, have a single pipe, fabricate the thing in the shop, a lot easier to erect. Having this model early on really helped convince the architect was never convinced. He always wanted his treed option. But when we were able to present the owner the cost savings on this thing, it was a no-brainer. So getting the fabricator involved earlier with this model really helped. So there was the 3D model, and there was the thing in place, and they look pretty slick. The architect won't admit that, but the owner loves it. The second project I'm going to highlight with them is a 4-story, 144,000 square foot hospital. Some data on this. This constructability method data is for that 4-story, 144,000 square foot hospital. The data under traditional method is a similar hospital that owner had built a couple years prior using the traditional design bid build method. The big thing here is total duration of the project. Similar square footage, similar stories, everything was fairly similar. Constructability method, design time 10 weeks in traditional. Bid and estimate time, 0 in constructability method because everybody was involved earlier. Everyone started developing their costs from day one. So we gained 4 weeks. Award time, he had already selected the team because it was a team he knew and a team he trusted. So we're up to saving 5 weeks. Prepare the ABM, probably less than a day, but we had to put a day down. With a traditional method, 3 weeks. get down to the bottom here, we saved 17 weeks. And financially, this is how it came out. And somebody asked the question yesterday, does this include the cost of the money over those additional 17 weeks? It does not. This is just the cost of the steel. So that's a great owner. Just a comment from the construction manager. We're running out of time, but he thought it was great. And the proof is in the pudding. We're working on yet another 100,000 square foot hospital for this owner, same design team. Second case study, Charter Steel Melt Shop facility. This is in the Cleveland area. It's about 100,000 square foot in 3 adjacent structures. 110 foot tall on the melt shop portion. It houses 2 200-ton overhead cranes. The fabricator approached us on this project. So whatever delivery method you want to call it, we feel it's called constructability because everyone worked together from the beginning to get this thing done. But we started designing essentially in January of 2005. And we had the project team had the 200,000 tons of steel substantially erected in November of 2005. Tight schedule. Week 1 in January of 2005, we began structural design. The fabricator had worked out his schedule even prior to coming to us to design the thing and realized that detailing needed to begin in week 3. Shop drawing review needed to begin in week 5. So he told us, obviously, the long lead items. We need to get main truss material ordered. We need to get heavy column shapes ordered. We need to get plate girder plates ordered, crane girder plates ordered. So everyone working together, determining what the schedule is, determining what the priorities are. So we were reviewing shop drawings on the crane girders in some cases before we had even designed, the backup truss on that crane girder. So a lot of coordination with the schedule, a lot of coordination with the details. Truss design preferences. The fabricator said, the way I want to do this is I want wide flanges, top and bottom chords laid on their sides, wide flange web members, make them all the same depth, even if it costs us a little tonnage. Then all I got to do, slap a gusset plate on the side. I don't have any spacers, don't have any shims, weld it home, send it out. This obviously, when you got the wide flanges laid on their sides, saved a ton erecting the thing because you didn't have any lateral bracing when you were just hanging those trusses up there. So great fabricator input on that item. 100-foot crane girder supporting a 200-ton crane. The guy who was fabbing the crane girders had 40-ton lift capacity in his shop. First go around designing this crane girder, it was about 60 tons. We had a lot of different iterations. We made it a fish belly, lightened this thing up, got it down to 45 tons, kind of coordinated an engineered lift in his shop. He was able to lift the 45 tons. But obviously, if that thing comes out in traditional method, the fabricator's got to lift that 60-ton girder in his shop. It almost keeps him from doing the project, or keeps him from doing that girder. And there's that 100-foot girder in place. Just another gratuitous shot of that building. In the previous example, I emphasized a lot of the technical things we used to enhance that project using BIM, given the model early on. This is one of the detailer's drawings from that project. This was in 2005, so it wasn't that long ago. Everything hand-drawn. Nothing on the computer. We didn't give him a model. The key there was just collaboration among the parties. A lot of faxes going back and forth too. Fabricator didn't even, or the detailer didn't like to use email. So, a lot of the emphasis today is on BIM technology advances. Things are pushing us toward that collaboration among all the parties, but constructability, the philosophy, doesn't rely on BIM, it just relies on collaboration. BIM obviously helps in some cases, but it's not 100% necessary. So, quick summary, constructability meets reality. I'm running out of time here. This is the graph Jay showed earlier. Your ability as a fabricator to influence the cost is greatly increased the earlier you get involved in a project. The cost to make changes, the later you get in a project, obviously the cost goes up. Impact of BIM and integrated project delivery. I read an article in Business Week, and I'm sorry I don't have it on a slide, but something like Business Week, and it caught the flavor exactly of what we're doing here. So I'm going to just read you a quick section of it. The title of the article is Creating Collaboration Takes More Than Technology. Why should an organization adopt collaboration? One reason, value creation. With this growing consciousness for collaboration, many companies are investing in collaboration tools and technologies, things such as BIM. What they're finding out is that they think they can just adopt the tools and collaboration will occur. That's not the case. I'll read from the articles again. Are the tools the problem? No. More likely the problem is the organization. When I'm talking about the organization here, I'm talking about the traditional construction community. You know, we're not used to working together. It's a competitive environment. As fabricators, one of my first jobs with Ruby and Associates, we were working with a fabricator. And back in the early 90s when I started, the dress code at Ruby and Associates was you wore a tie every day. So I had a meeting with a fabricator one day at his shop, and I had a tie on, and I walked in, and I said, "Hi, how you doing?" He says, "John, first thing you got to do is take off that tie." And I'm like, "What? Why is that?" And he goes, "If they find out you're an engineer, that's just going to give them another thing to grab." And that's stuck in my mind, just the evolution of as far as what I've seen from acceptance from fabricators to talk to engineers. You know, during Steel Day, you guys are having people into your shops. I've seen an evolution in fabricators to become more accepting of discussing things with engineers. The onus is also on the engineers to be more accepting of listening to fabricator input. So that article really caught me. Organizations adopt tools for the wrong reason, primarily the belief that tools will create collaboration. Tools merely offer the potential for collaboration. Talks about the competitive nature of organizations and how it inhibits tools from improving the process. Same thing with IPD. A contract can't make you collaborate. Well, it can make you collaborate, but it needs to be willing collaboration. So those are things that we're going through today. Barriers to collaboration, that lack of trust with, you know, a fabricator grabbing my tie. Those barriers are falling. Perceptions, talked about it a little earlier. If a fabricator offers suggestions at the value engineering phase after he gets the bid documents, the engineer perceives that as criticism. Engineers need to get past that. Fabricator input discounted. A lot of times the owner, if he gets comments from fabricators at that point, he's going to see it as self-serving for the fabricator. So we need to educate owners on the fact that it has a real cost to his project. Again, business opportunities, I discussed it. I know you guys are doing a great job trying to change your mindset as far as how collaboration goes, so that you're not just the guy who details and provides the steels, but you're a value-added provider, giving good input to the owner on cost and schedule. Continuing to cultivate that mindset in your organizations is going to give you a competitive advantage as we go forward in this construction industry environment, which is being driven more toward collaboration. I'll read the PDH code again before I answer questions. I know we're running out of time. It's V as in Victor, D as in Dog, 97F. And any questions? Yes?
Yeah, just one. I assume, if we're making the assumption that it isn't a fabricator you worked with previously, that you were talking about there, I assume that the owner, the architect, and the structural engineer will be involved in picking the fabricator that you want to work with to bring into the team at the early stage. What's the number one attribute you're looking for? What are you looking for?
Familiarity, trust, someone we can trust. Usually it's someone we've worked with a lot before, or someone that the CM works before. In the case of those hospitals, the fabricator actually brought us in on that project, and I'm not sure if they were the original fabricator who performed that function from the owner or not. But when we look for attributes in a fabricator, it's mainly trust is the number one thing, and obviously you need to have worked with somebody in the past to develop that trust. If you've sat through any of the other constructability sessions, it's not the low-cost guy we're looking for, the low dollars per ton guy we're looking for. It's someone who's willing to work with us and someone we trust. And most, the owner is the guy who drives everything. Without it, those hospital projects are so successful because that was the smartest owner I think I've ever seen. I mean, he knew what we were providing. He didn't write us a blank check at the beginning, but he trusted us, and we weren't going to kill the goose that laid the golden egg. So everybody knew there was a backlog of projects. No one was going to screw that owner. Everybody looked out for his best interests, and it was a great project team. So, long answer, that was it, but trust is probably the short answer.
What would you say is the main reason that owners don't?
I have no idea. A lot of politics involved. We've had successes on a couple projects with the same owner. That owner's rep has gone. But we took the same project team to a different owner's rep within that organization, showed him all our successes, money we saved, schedules we beat, and we didn't even make the top 6. My fear is that this was in a different region, there were politics involved, that owner's rep wanted to give it to a different group for, it's the old boys network. We all are involved with it. It benefits us in certain regions. It benefits other people. But, it's...
I have a question on your team. Up front, you have a construction manager involved or the general contractor?
Construction manager.
What was the general contractor brought for?
The CM served as the general contractor. I'm not sure what you'd actually call him on that, but it was a company that did both GC and CM work, and they managed all the parties and managed all the work in the field. They were the construction guys. I'm not sure what their title was, and I don't think they were either.
People are invested in the collaboration as well.
Yep. Yes.
Did they perform any work on site? Did they self-perform anything?
No, they didn't. Yes.
I believe in giving a seminar specifying engineers to use current standards and standards that actually exist in existing.
I don't know, Dave. When are you going to give me time to do that?
Just a comment more than anything.
Yeah.
So many things and standards that don't exist, that existed before my lifetime, have been updated.
Well, and that's a maddening thing, and it's 2:15. There's a coffee break now, so I won't let any of you out. There's a seminar here this week, I think it was right now, that addresses code changes. And I'm not, if there's an in-depth IBC question that comes into our office, I'm not equipped to handle it a lot of times. Our younger people who deal with that stuff every day, you know, they're equipped to handle it. I can delve into it and do it. Even some AISC connection design stuff, I need to research it because I don't do it every day. Things are changing so fast, and I know it's maddening to get outdated specs and outdated standards in your project documents. You know, I think I can speak for all engineers. We try not to do that, but things change so fast. I'm really looking to go to that codes and standards seminar, and they're going to maybe give us the magic solution on how to handle all that. Because, I mean, things are changing every 3 years, and then you got different organizations, so there's a lot of documents to keep up to date on.
Very good, John.
All these presentations, the previous ones and the one for erectors, are going to be at rubyuniversity.com. You can log on those. I think some of the earlier ones might already be on there. There's also several articles that Dave and Jay and other people in our office have written with regard to our constructability philosophy.
We expect that to be populated probably by the end of next week. Well, it's up now. So, right? And one of the other things I would just mention on this design guide, when you read it and what we talked about here, I'm sure these are things that you focus on all the time. But understand that designer speaks designer and you speak fabricator, and those are two different languages. And the information in the book is what the designer wrote the book with the designer. But understand that you, as a fabricator, you have a lot to say and an awful lot to add to that design process, design decision making. And we're encouraging you to get involved in however you can do that within your organization, within regular meetings of engineers, expressing and sharing things. I told the designers earlier today that what I would recommend they start to do is have post-job audits and invite the contractor in and talk about the project. What was good, what was bad, what could we improve? And I said, I don't expect the first one to be successful. But if you call them back the second or third time, the fabricators will believe you're serious. So we start to get a dialogue. That's the intent of what we're trying to do. Any other questions?
Was there something in particular that sparked this business philosophy within Ruby and Associates? And have you seen a return for your company in being more proactive and working with fabricators?
I think the thing that sparked it is the fact that Dave used to work for American Bridge, and is that correct?
What I shared earlier is when I came to work for American Bridge in 1960, I spent 2 years in the drawing room. And then out of the next 5 years, I spent 3 years working with American Bridge, which is functioning for U.S. Steel Marketing. And it was my responsibility to review every structure that was going to be built between the Pennsylvania state line and the Rocky Mountains, whether it was steel or concrete, and for me to find a way to do it better. And now I have a hard time looking at a set of drawings or looking at an issue without thinking, how can I do this better? How can I be more efficient? How can I make it safer? Or how can I reduce pieces, reduce man-hours? And it's just something that it's hard for me to do. Today I was looking at one of the detailers and they were showing me these details of these companies' projects. And he said, you know, some of these things are full of pieces. And my wife was with me. When I walked away, she says, I know what you were thinking. You saw all those pieces. You were trying to say, how can I get rid of all those pieces? And in fact, I'm looking at it and saying, why are they all there? So I just cannot not do that. I try to instill it in the group that we have. And as we primarily are service contractors. Design build, erection, connection design, erection procedures, installation, stability analysis of concrete and or steel. That's 90% of our business. Thank you.
Thank you very much.
Thank you.